Are you done this one? Okay, students, we are coming. Okay. So one only joined in that one. Okay. Yesterday we discussed about the second block, that is particularly we discussed the organic part. In that organic part, alkalides, terpenoids, and the strategies of the what are the stereochemistry and what are the reaction strategies we are following that we are discussed in the organic part. Now we're already started last yesterday only the physical chemistry. The unit 7 is the catalysis. Catalysis means catalyst which are used in that one. That is called as a catalysis. The catalysis is mainly important of the, it will increase the rate of the reaction but does not participate in the chemical reaction. That is called as a catalyst. Okay. So during of the catalyst, what the type of the reactions which are following? So in the particularly you are using of the this foreign substance is called as a catalyst which are used that is not participating that one in a chemical reaction. So mainly important in that catalysis, the unit 7, we have discussed the general principles and properties of the catalyst. Okay. So catalyst must be properties having of the catalyst remain unchanged in mass and chemical composition and end of the reaction. That is a main important property which you have to follow that one. Then only you can choose that particular catalyst. Okay. Suppose you are regularly using of the nickel, platinum, iron. Most of the D block elements are act as a catalyst only. You know that one. D block elements are very important. They are metals. They form the color complex. They are act as a catalyst. That's why your plenty of the complex compounds are formed. That one. So in this catalyst, whatever the catalyst, the first property is it does not change its mass as well as the chemical composition at the end of the reaction. And also the second property, a small quantity of the catalyst is generally sufficient for the catalyze the reaction. Only small quantity. So it is a main important one, and most of the heterogeneous reaction, the rate reaction is increases with the increasing of the surface area. So third property is the catalyst cannot initiate the reaction. The catalyst cannot be initiate the reaction. The function of the catalyst is alter the speed of the reaction. If you know the property of the catalyst, the mass does not changes, chemical composition does not changes, and small quantity of the what catalyst is required. And also catalyst is we are using in the reaction, it does not initiate the reaction but the increase the speed of the reaction. That is an important property of that one. And also it is the action of the catalyst is specific nature will be there, and it does not change the chemical reaction equilibrium. The catalyst cannot change the position of the equilibrium in case of reversible reaction. So reversible reaction means it can form the both reactants. When reactants are react each other, formation of the products again will be converted into reactant. That is the reverse. That is the equilibrium state. So the catalyst cannot be changed the position of the equilibrium. And the next is the nature of the product formed by the unaltered by the presence of the calcium. That means whatever the product is formed, the catalyst does not altered. If it is altered means it will be does not use of the, that means it is involved in the chemical reaction. There is a very important property, and some catalysts are used particular temperature only. The efficiency is very important. That means at that temperature only the catalyst is effectively take the reaction participating, and the efficiency will be 100%. That particular temperature is called as optimum temperature. So if you know that Haber's process or contact process, sulfuric acid formation, vanadium pentoxide used in the optimum condition of the temperature is required. The temperature is 400 degrees Celsius, the temperature is required. That temperature is called as optimum temperature. So that we are using of the catalyst, very important, the principles and the properties are very important to choosing of the catalyst. Okay. And here during the catalyst, we are using of the promoters also used. The promoters are small quantity of the promoter is added to the catalyst. Why? Because this catalyst which we are having of the small quantity, that increase their efficiency purpose. Efficiency purpose, increasing of efficiency purpose, we are adding a small amount of other substance in the, apart from the catalyst, we are using that other substance is called as catalytic promoter. Sir, what is the catalytic promoter means? This example already you know that Haber's process, we are preparing the ammonia. In that Haber's process, ammonia, iron is act as a catalyst. Okay. Finally divide iron is act as a catalyst. But when you are adding small quantity of the molybdenum, MO, molybdenum is added, molybdenum act as a promoter, which gives the more efficiency of the ammonia molecule. That means the product is obtained is a very important. That is efficiency will be more and more. That called as a ammonia is a very important promoter. That means molybdenum is act as a promoter, which gives the efficiency of that chemical reaction end of the product. Just like you are using of the preparation of the methyl alcohol from the water gas, you are using of the chromic acid is used as a promoter when the catalyst is zinc oxide is there. Zinc oxide is a catalyst. When you are adding of the chromic acid is a promoter, the methyl alcohol is efficiency is more. Then my product will be obtained. Very, very important. And you know one more regularly using of hydrogenation of the oils. Hydrogenation is mostly nickel catalyst is used. Nickel catalyst is used when you are adding of the copper is the promoter. The reaction is very fast and efficiency is very more. That particular hydrogenation. That means when the unsaturated fatty acid is converted into edible oil, that edible oil is formed. Okay, this is about the main important of the promoters. So in the three cases we are using of that one. That means the examples I given that one, three cases that promoter is used. And one more is called as second type of category is catalytic poison. Already I told that catalytic poison is nothing but retard the chemical reaction. That means decrease the chemical reaction or stop sometimes. The reaction does not proceed. That is called as a catalytic poison. So here the activity of the catalyst in the presence of that one, it will be destroy or retard the reaction. The substances will be decreases. That means that is called as a catalytic poison. So here used as in the particularly sulfuric acid process in the contact process, the catalyst is used as a platinum is used. So arsenic oxide is act as a catalytic poison. That means substance retard the activity. The activity of the substances will be read. Why? Because in the, during the contact process, sulfuric acid is formed when the sulfur dioxide is treated with the oxygen, formation of sulfur trioxide. When the sulfur trioxide is during the hydrolysis, we are getting of the sulfuric acid. That means oleum, and you are formation of after the oleum, you are getting of the sulfuric acid. So this is a form the oleum. That means H2SO7 is formed. On the basis of that one, then you are concentrated of that particular volume, you are getting of the sulfuric acid. At that time, the substance, when we sulfur dioxide substance activity will be retarded by means of adding of particularly arsenic oxide is added. Okay, so that will be happen. Even though in the Haber's process, formation of the ammonia, when you are using of the iron is a catalyst. So ammonia, if you are, that means sulfuric acid, that is hydrogen sulfide or carbon monoxide is if you are added, then the rate of the reaction, that means the reaction will be retarded, will be take place. It is called as a carbon monoxide or manganese arsenic oxide is act as a catalytic poisons. Okay, this we are to very important for very short bit. What is the catalytic promoters? What is the catalytic poisons? Okay, and the principles and properties are also very important. 5 to 6 principles are there. What is the means? First principle is it does not changes the mass and the chemical composition. We take the small quantity always, and the catalyst is does not initiate the reaction, but it increases the speed of the reaction, and also it is having of the specific nature is there. and also it does not alter the unaltered of the presence of the cat. That means product is unaltered. And also some catalyst used at particular temperature. It is a more efficiency. That particular temperature is called as optimum temperature. Okay, these are the properties you can write. And what do you mean by the promoter means adding up that one, we are getting efficiency will be more. Catalytic poison means is nothing, retard the reaction. That you have to remember in the examination point of view. And few examples, if you write, you will get that one. Okay. Next, the classification of the catalysis. Catalysis means we are having of the two types of catalysis. They classified the catalysis in two types: homogeneous catalysis and heterogeneous catalysis. Already yesterday I told that homogeneous catalysis means in the chemical properties we are using of the A-bus process. When you are adding of the ammonia, separation of the ammonia, we are taking as the nitrogen oxygen in the gas state, and formation of ammonia is also gas state. But in the catalyst is what you are using, the catalyst is iron is solid state. So depending on the all the whatever the you are using the substrates, that must be, that means reactants as well as the product and also catalyst must be in the same phase. That phase is called as homogeneous catalysis. Best example for the preparation of the sulfuric acid by the contact process. In the sulfuric acid, preparation of the sulfuric acid in the contact process, we are initially used as sulfur dioxide and oxygen. Sulfur dioxide is in a gas state, oxygen is in gas state. Then using of the sulfur trioxide is formed. In that, nitric oxide is used. Nitric oxide also in the gas state. So that reaction is called as homogeneous catalysis. That reaction is called as homogeneous catalysis. So here the catalysis is classified into two types: homogeneous and also heterogeneous. Homogeneous and heterogeneous. These are the two are there. Homogeneous catalysis and heterogeneous. Here the homogeneous means all the reactants, products as well as the catalyst will be in the same phase. That is called as homogeneous. Just example, I am taking the sulfur dioxide, oxygen, formation of sulfur trioxide, and the nitric oxide is act as a catalyst. It is also in the gas state. It is gas state. It is gas state. It is gas state. This is called as homogeneous catalysis. Okay, and hydrolysis of sucrose. That means sugar crystals will be hydrolyzed in presence of sulfuric acid. So if you are using of the one more examples of homogeneous catalysis, hydrolysis of sugar. Sugar means C12H22O11. When the hydrolyzed, we are getting off in presence of sulfuric acid. Okay, formation of glucose C6H12O6 plus fructose C6H12O6. All are liquids. This is a liquid, it is a liquid, it is a liquid, it is a liquid, it is also liquid. Same phase, it is called as homogeneous. All are in the same phase is called as homogeneous. And also you are using of the chemical kinetics hydrolysis of methyl acetate. Hydrolysis of methyl acetate is also used as that one. Proton is act as means HCl is added. That is also in the liquid state. Hydrolysis of methyl acetate also formation of acetic acid and a methanol is formed. That is also examples of homogeneous catalysis. Okay, so very easy for the classification of catalysis. If it is a same phases are same phase is called as homogeneous. In different phases are called as heterogeneous. Okay, so heterogeneous example you can write the ever process. You are using of the nitrogen oxygen, formation of ammonia. See, this is the gas state, it is gas state, it is the gas state. But when we are taking the iron, finely divided iron, iron is in the solid state. That is called as heterogeneous catalysis. Okay, then the iron is called as a heterogeneous catalysis. Similar way, if you are taking of this also in the Haber's process, sorry, in the contact process, I am using of the nitric oxide is a gas. But suppose in the contact process we are using of the, that means sulfur dioxide plus oxygen in presence of platinum. In presence of platinum, it is in solid formation of sulfur trioxide. It is gas state. It is gas state. It is also gas state. All are in the gas state. So, but only the catalyst is the solid state. That's why it is called as heterogeneous catalysis. Now we take the hydrogenation of the oils. Hydrogenation of oil means vegetable oil. Vegetable oil is hydrogenated. We are getting off edible oil. So edible oil is formed. That is the main important catalyst is nickel is the catalyst. Nickel catalyst is the solid state. Remaining are vegetable oil liquid state, hydrogen is gas state, and also edible oil is the liquid state. Different phases are there. Those are called as heterogeneous. Okay. If you take the third example of this one, vegetable oil. It is in liquid state. Hydrogen, it is in a gas state. Catalyst, nickel is a solid state. And formation of edible oil. Edible oil is liquid state. Okay. This is nothing but we are formation of this. These are all examples of the heterogeneous catalysis. So here also you can take the hydrolysis of methyl estates. This is hydrolysis of methyl estates. It is in liquid state. It is also liquid state. We are getting of the liquid state that will be formed, and also in presence of proton means H plus that will be obtained from the HCl. It is also liquid state. Formation of acetic acid and also methanol. Sorry. This is the formation of, so you are having of the methyl acetate. We are using the methyl acetate, not ethyl acetate. This is a methyl acetate use hydrolysis of methyl acetate. Acetic acid is formed and methanol is formed. Hydrolysis H plus proton is attacked on this one. We are getting of this one. These are the three examples of the homogeneous. These are three examples of the heterogeneous catalysis. Okay. So this is about the homogeneous and heterogeneous catalysis. Okay. So the next examples we are using of this one. And in this case, some catalysis are there. Two types of homogeneous, heterogeneous only. Next, positive catalysis. What do you mean by positive catalysis? What is meaning by the negative catalysis? What do you mean by the autocatalysis? What is meaning by the induced catalysis? So it is a fun 10 marks question, sometimes 20 marks question. These are the four are important of what do you mean by the positive catalysis. Positive catalysis is nothing but the rate of reaction is accelerated by the foreign substance. The rate of reaction is accelerated by the foreign substance is called as positive catalysis. Nothing but. Just like you are using of, it means what is catalytic promoter. What you have, the efficiency will be increases. And also rate of the reaction will be increases. That is a positive. We are using the promoter. But same meaning is that the positive catalysis is nothing but the reaction is accelerated by the foreign substance. Foreign means catalyst is called as positive catalysis. So potassium chlorate in presence of manganese dioxide, formation of potassium chloride and oxygen. Here manganese dioxide acts as a catalyst which is used as a foreign substance which increase the rate of the reaction, accelerate the reaction, that is called as positive catalysis. Okay, similar manner you can take either sulfur dioxide, that means sulfur trioxide preparation, platinum, asbestos platinum or vanadium pentoxide in the Haber's process. In the contact process different, Haber's process different. Okay, so by means of the here vanadium pentoxide is used as a catalyst vanadium pentoxide used as this will be accelerated by the rate of reaction getting of the sulfur trioxide. Okay. So synthesis of the ammonia also in the Haber process, instead of the iron is the optimum condition. That means optimum condition means you have to maintain the temperature is 450 to 500 degrees Celsius. That is the optimum condition is there. At the time that a reaction will be proceeds, accelerate very fastly, that optimum temperature is, those are called as positive catalysis. Negative catalysis means nothing but when the certain added, whatever the foreign substance is added, instead of increasing the rate of reaction, it is decreases. Actually, when catalyst is added, means it will accelerated. But suppose some of the catalyst is added, does not accelerate, rate of reaction does not increases, it decreases the rate of reaction. Such catalysts are called as negative catalyst. So negative catalyst is particularly decomposition of hydrogen peroxide. Hydrogen peroxide decomposition, when glycerin is added, it slow down the reaction. Why? Because we are preparing the hydrogen peroxide, we are preparing the laboratory. When this hydrogen peroxide is keep in the bottles, when it is exposed to the sunlight, what happens? Within a few minutes, it will be formed into water and oxygen. So I want to use as an antiseptic hydrogen peroxide for the medicinal field. That's why the particular companies added to the particular hydrogen peroxide, small amount of glycerin is added. If your glycerin is added to the hydrogen peroxide, what happens? It retards the reaction. That means instead of increasing reaction, it decreases the reaction. That means the hydrogen peroxide does not fastly decompose. It slow decomposition takes place. Anyhow, decomposition takes place, but the slow reaction will be there. Very, very slow when you are adding up the glycerin. Okay. This glycerin is act as a negative catalyst. Okay. So very important in your exam laboratory. If you go to the organic solvents are there, reagents, carbon tetrachloride is, chloroform is there. Chloroform is preserved in the brown colored bottle, if you observed or not. But carbon tetrachloride is present in the white colored but transparent bottles. If you observe that one, why they are keeping up the brown colored bottles? Chloroform. The same property, just like the hydrogen peroxide. Chloroform is when you are exposed to the sunlight or exposed to the air also. The chloroform directly converted into carbon tetrachloride. This is nothing but the chain reaction in the formation of the halogenation of the methane. Halogenation of the methane in the first sem it is there. When the methane is halogenated, that means chlorination. When the hydrogen halide, that means we are using of the HCl. Simply formation of, there's a chlorination will be takes, that means halogenation will be takes place. Formation of methyl chloride and HCl is formed. When methyl chloride is again chlorinated, formation of methylene dichloride, HCl is a byproduct. Methylene dichloride again halogenated, that means chlorinated. So formation of chloroform, CHCl3. Every time one proton, one chlorine atom is eliminated out in the reaction. That is a chain reaction. Okay. That is called as halogenation of the methane, particularly chlorination of the methane. So lastly, you are getting of the reaction in the chain reaction, carbon tetrachloride ultimately formed. So this you can stop with the help of that particular adding of this chloroform. When you are does not react with the oxygen or slowly retard the reaction, means you are adding of the alcohol. Alcohol is act as a negative catalyst. Please remember, hydrogen peroxide slow decomposition means you have to add the glycerin. Chloroform slowly converted into carbon tetrachloride means you can add as a alcohol. Alcohol is added to that one, that is called as, this alcohol is called as negative catalyst. I hope two are easily you are differentiating. Positive catalyst means it increases the rate of the reaction. Negative catalyst means it will retard the reaction or decrease the rate of the reaction. That is only the important positive, negative. And one more is called as autocatalysis. Autocatalysis is nothing but in that reaction, one of the product is act as a catalyst. One of the product is act as a catalyst. this is very important. We are using of the semi micro analysis during of the, that means preparation of the acids and bases, or the what do you mean by the, you are prepare that particularly oxalic acid is treated with the potassium permanganate. The 8 reactions are there. These are the first chemical reactions are when you are using of the potassium permanganate, purple color slowly decolorizes first, very slowly when you are adding of the oxalic acid. But after the formation of the manganese plus 2 ion, this manganese plus 2 ion in the products which can act as a catalyst, then immediately decolorizes very fastly by potassium permanganate when you are adding up the small amount of oxalic acid. So manganese is act as a autocatalysis. That means product itself act as a catalyst here. This process is called as autocatalysis. Okay. I hope you understand the particular thing. Even though hydrolysis of ester, in that acid is formed by the product acid. That acid is in the ester is autocatalyzed by the acid. So ester means RCOOR dash, whatever that one. So methyl, whatever the acetate or ethyl acetate, what you are using of hydrolyze. In that, when do hydrolyze formation of the, one is the acid, one is the alcohol is formed during the hydrolysis. But initially the acid is formed in the product. That acid itself acts as a catalyst. That is called as autocatalysis. Next is induced catalysis. Induced catalysis means here one of the reaction is influenced by the second reaction, another reaction. One of the reaction influenced by the other reaction means it's a mixture of the reaction, nothing but. When sodium arsenate, preparation of that one, in that sodium arsenate, sodium sulfite is act as a induced catalyst. That means sodium sulfite is oxygenated for the formation of sodium sulfide. This sodium sulfide, when the next reaction, sodium arsenate, for the purpose of oxidation purpose, that means easily oxidizing with the help of the oxygen in presence of sodium sulfite. So sodium sulfide is the one reaction. Sodium arsenate is the one reaction. Both are oxidizing with the help of the oxidation under normal. This it is under normal condition means small amount of oxygen is added. Then this particular sodium sulfide is act as a sodium arsenate to oxidize. That particular reaction is called as induced catalysis. That means sodium sulfide is act as an induced catalyst. I hope this is a little bit of confusion. Here mixture of reactions are there. In that mixture of reaction, both substrate can oxidizing. One substrate, sodium sulfide, is oxidized, formation of sulfur and sulfate. That sodium sulfide is next sodium arsenate will be oxidizing purpose. This sodium sulfide is act as a catalyst. So easily oxidized by the sodium arsenate with the help of the sodium sulfide. So sodium sulfide is called as a induced catalyst. That's it. Both is different reaction. Both are the different reaction. But in the case that sodium sulfide, here it is a mixture of the reaction. That's why it is a using of that one. Okay. నేను ఒక్క నిమిషం మీకు క్లాస్లో ఉన్నారా ఆన్లైన్ క్లాస్లో ఉన్నారా So this is called as induced method. So examples, that is a very important classification now. So here the classification is having of the two types, homogeneous, heterogeneous, positive catalysis, negative catalysis, and also you are having of autocatalysis, induced catalysis. Okay. So we are having of mainly important of the, this is a 20 marks question. Homogeneous, simply all the same phases. Heterogeneous, different phases. Positive means increase the rate of the reaction. Negative means retard the reaction. Autocatalysis means in that product itself act as a, the product of the means one of the product in the chemical reaction act as a catalyst. It is called as autocatalysis. Induced catalysis means mixture of reaction. One of the reaction is act as a catalyst to the another reaction. Catalyst means accelerate the reaction. So another reaction will be accelerated by the first reaction. That system is called as induced catalysis. Okay. So I hope you can understand this one. It is a compulsory question in the examination point of view. So why? Because this is a very important topic. I given a lot of time on this particular one. Why? Because it is a very easy to understand. Next 8th chapter, I will go to the what are the important things. Just note down that one. You'll getting of any doubt means please contact me. I already given the phone number. So in the chapter 8, homogeneous catalysis. Only we are discussing about the homogeneous catalysis. In that, mainly important of the mechanism of the homogeneous catalysis. Page number that is 106. Acid-base catalysis 108. Hydrogenation of alkenes. Page number 111.
Sir, in page number 109, is all mechanism we have to remember.
No, not like that. See specific acid catalysis. Just first reaction, if you see that one.
Yes, sir.
That is hydrolysis, na? You are getting of the acid and alcohol. That
Yes,
is
sir.
methyl estate, nothing but don't confuse that one. RR. You are taking of the alkyl group is methyl group. Both alkyls are methyl group we are taken. It is nothing but methyl estate. When the methyl estate, methyl estate, this third reaction. Methyl estate hydrolysis, you are getting of the acid and alcohol. That mechanism you show. No need of remaining others. So even though it is given again, the different alkyl groups are given. Ethyl estate is given in the mechanism. One R is the methyl group, another R dash is ethyl group is taken in the mechanism. You can take both are methyl group. Easily you are getting of the acetic acid and methanol. That's it. So that mechanism is you taken as. Same manner, not all the important, this is the intermediate products. You won't write directly, you can writing of the acid and alcohol is formed. How the acid, the hydrogenation is, proton is eliminated out. That you have to take as. Proton is adding and another is the negative ion will be, that means acetate ion. Acetate ion is attacked with the H plus ion, formation of acetic acid. Next, ethyl ion, that means alcohol is formed. There also proton is required. That is another next formation will be alcohol is formed. That is enough for the acid-base catalysis. Next is the hydrogenation of alkenes. Alkenes, hydrogenation means adding of hydrogen. Already in the first sem you are adding up. How to prepare the alkenes means when the alkynes is treated with hydrogen in presence of nickel catalyst, formation of, that means CnH2n plus H2 you are adding, you are getting of CnH2n minus, that is using of that one, the triple bond is eliminated out, formation of the one hydrogen. So CnH2n plus 2 you are getting of, that is alkenes, like that all the hydrogenation is takes place. Here you are adding of the catalyst is, we are using nickel catalyst. That is only representing of the formula. Okay, double bond is formed. The hydrogen is attacked on the alkene groups. Then the single bond. That means double bond. One bond is broken out. 5 bond is broken out. Formation of the alkanes. Alkane is formed. CH3. So you don't want like this. Here, what is the symmetrical formation will be? Dotted lines, solid lines. No need of just double bond is there. Where it is broken, hydrogen is where is attacking in presence of the catalyst, nickel catalyst. That is called as hydrogenation of alkenes. One more important is hydroformylation of alkenes also. Hydroformylation, sometimes it is asking. Remaining other structures, no need. Whatever the reactions are there, this is the only hydrogenation of alkenes in the triple one. We are having of 3 steps is there. That is enough. Next page, we are having of a remaining other is no need of that one. And also practice hydroformylation of alkenes. That is only in that chapter. Least that is also Wacker oxidation of the alkene, also asking for, it is a laborious process. You leave with that. Next, now go to the 9th chapter. Why? Because I want to give the important questions within the 10 minutes. Heterogeneous catalysis. In that, the important of 123 synthesis of ammonia by the Haber's process. Iron is a catalyst, molybdenum is the promoter. Page 123. That's enough. What is the synthesis of ammonia and sulfur dioxide oxidation? Alkene polymerization. Alkene polymerization. Very, very important. And applications of zeolites. Zeolites are naturally occurring synthetic microporous aluminum silicates. Aluminum silicates is called as zeolites. Very, very important. Compulsory short bit. 125. Applications of zeolites. That's it. In that particularly heterogeneous catalysis. Only the important is the zeolites. Next is the alkene polymerization. Next we go to the spectra black 4. Spectra only limited topics you can cover it. Don't worry about the spectra. Why? Because it's a laborious process. You can't understand easily. With the practical orientation only you can understand the spectra. You are having the two spectra, NMR spectra and mass spectra. In the NMR spectra, you are having of the page numbers 133, origin of mass spectra, principles of mass spectra. Very important is the principle of mass spectra. And schematic diagram. In the page number 135, it is given. They ask, draw the neatly diagram of mass spectra and what are the principles is involved in that one. For the 10 marks or maybe it is a 20 marks question in the mass spectra. So the diagram also very complicated also. Just practice it if you want. Otherwise, already 80 marks is covered. My syllabus is. It is extra only. If you want that one, you will go this only one question from the mass spectra. I don't want to give the. Next is the nitrogen rule. One more. And one is the rule of 13. Page 141. Rule of 13 is there. Rule of 13 is nothing but when any organic compound or any compound molecular weight is divided by the 13, you are getting of the one number. That number is nothing but the molecular formula of that one. Okay. If the benzene is taken, benzene molecular weight is 78. 78 is divided by 13. You are getting of 6. That means C6H6. The molecular formula is C6H6. You can find out with the help of this rule of 13. That's it.
So we have to learn molecular weight, no, sir, for that?
Molecular weight. You have to take the molecular weight and divide the with 13. If suppose 13 you are exactly divisible means you are getting of the carbon number of carbon atoms. If any remainder is there, that is nothing but remainder is nothing but the number of hydrogen atoms are increases. Suppose if instead of 78 benzene, I am taking of 80. So 13 is divided by the 80 means 78 is divisible 6 times. Remainder will be 2 is there. C6H8 is the molecular formula for that. That is called as a rule of 13. I hope understand na?
Yes, sir, yes.
Benzene molecular weight amma. It is exactly divisible by the 13. So 6 is number you are getting up. So the molecular formula of benzene is C6H6. That's it. If any remainder is there, that remainder will be added to the hydrogens. That is called as hydrocarbons. This is called as a rule of 13. Okay. So that is about the mass spectra. And one more, if possible, metastable peaks 144. It is total critical matter. Fragmentation takes place. We are having of the fragmentation that the metastable peaks are present. By means of the metastable peaks, we have to find out that a mass spectra peak is observed. By that peak, you can identify whether it is a what type of group is there, whether it is a methyl group is there, hydroxy group or aldehyde group or that is a carboxylic group or amine. Like that, we are estimated with the help of the peaks only. This is about the very not that much of easy to understand the question. Okay. So only in the mass spectra, you can principles and diagram, neat diagram. Then rule of 13. That is important. Next goes to the NMR spectra. same NMR spectra, that is the principles of NMR spectra and neat diagram. That is diagram page number you are having of 156 is there. Go through that one. And next is what do you mean by the chemical shift? 158. And what meaning of that particular 163 spin-spin coupling? That's enough for your this NMR spectra.
Sir, after chemical shift,
Chemical shift, there's spin-spin coupling. Page number spin-spin coupling 163.
yes, sir, got it.
Okay, right. Next last chapter, that is introduction of the symmetry. Symmetry operations are there. In that almost all in the fourth sem we are heard about this symmetry operations. Here also some symmetry operations are there, particularly 173 page, rotational axis of symmetry. Rotational axis of symmetry, page 173. Only one equation, that means it is rotated 180 degrees. 180 degrees, the molecular formula will be rotating. We are getting off the left side, we are getting off the right side. That means nothing mirror image. It is nothing but the mirror image. When you see in the mirror, your left hand will become your right hand will become the left hand. That is in rotational axis of symmetry.
Like enantiomers.
Sorry, ma?
Enantiomers, sir.
Yes. Axis of symmetry, plane of symmetry, rotation symmetry, page 175, 173, 179, improper rotational axis. We take in any one of cuboids, or you can take the ethane staggered formulas or eclipse formulas. Anyone you have to explain with the help of this one, particularly improper rotational axis. You can take the cube, or you can take, pardon?
No, sir, nothing.
Okay.
That is enough, sir.
Okay, rotational axis of symmetry, that will be cubic form is there. In the example, ethane staggered form is there, ethane eclipse form is there. Any one you take for that one.
Okay, sir. Thank you, sir. Thank you very much.
181, center of symmetry. These are the questions likely to be asked like for 6 mm. Almost I covered that one, but on the particularly spectroscopic studies, mass spectra, principles, and need diagram. NMR spectra, principles, and need diagram. It is a essay type questions. Remaining all are the short bits. You can ask that one. And the rule of 13 also they are asking sometimes. Nitrogen rule of 13. That is the peaks, metastables, peaks also. There is a plane of symmetry, rotational axis of symmetry, center of symmetry. These are the questions which is asking for the 5 marks bits. Okay. So almost I covered. If anything is left or any doubt arises while you are preparing, please don't hesitate to ask. I given a number. Please do the phone call. But the evening hours I'm free. You can call it. I can explain.